Welcome to the deep dive. Today we're getting into something really interesting, the core ideas behind Cisco networking and collaboration.
Yeah, we've got these practice questions here for the Cisco 800-150 exam.
Exactly. And we're using them as like a springboard to quickly grasp the essentials, whether you're studying for a cert or just, tech curious. This should be useful.
Definitely. We're not just looking for answers, though. We want to pull out the real knowledge, the why. We'll cover everything from network models to troubleshooting to collaboration stuff.
Right. There are multiple choice, multiple response questions, the usual kind. But yeah, understanding why is the goal. Okay, let's jump in. First one, which OSI model layer handles MASI addressing and physical addressing? Options are data link, transport, application, network.
That one is the data link layer.
Layer 2.
Layer 2.
Wow.
Okay, so the data link layer, what's its specific job that involves MS addresses?
Well, fundamentally, layer 2 is all about getting data reliably across one specific part of your network, like your local LAN segment.
It takes the raw bits from the physical layer, layer 1, and packages them into frames. And inside those frames, that's where the MCC addresses are.
Ah.
They're those unique hardware IDs for your network card. Think of it maybe like street addresses for houses on the same street.
Right, local delivery.
Exactly. The MC address makes sure the frame gets to the right device on that specific local network segment. It's how your laptop finds the printer on the same Wi-Fi,
That local street address idea helps. So layer 2 is the local postman, sort of. What about sending something further away to a different network?
Well, that's where layer 3, the network layer, comes in.
Yeah.
It uses IP addresses, which are more like zip codes, for routing between different networks.
Gotcha.
But yeah, locally on that same street, it's all about layer 2 and those MP addresses for direct delivery.
Makes sense. Local MS, wider IP. Okay. Next question is about testing connections. What tool verifies end-to-end IP connectivity between two Cisco devices? Options: NetFlow, Ping, SNMP, Traceroute.
The classic tool for this is Ping.
Ping, yeah, you hear that one all the time. Seems so simple, but why is it considered so, fundamental for checking if things are talking?
It is simple, but incredibly useful for that first check. When you use Ping, you're basically sending out a little message, an ICMP echo request, to an IP address.
Okay.
If the device at that IP is online and reachable at the IP level, it should send back an ICMP echo reply. It's like shouting Marco and hoping to hear Polo back.
Yes.
It tells you if there's basic IP reachability. But, and this is important, just because a ping works doesn't mean everything is fine, all right?
Yeah.
Well, a firewall might block, say, web traffic, but still allow the ICMP messages that Ping uses. So Ping is a good start, but not the whole picture.
Good point. A first step, not the final word. Okay, moving to device maintenance. Which command is used to upgrade the Cisco iOS image? Options: copy flash.tftp, config terminal, copy tftp.flash, and reload.
For upgrading, you'd use copy tftp.flash.
Copy tftp.flash. Okay, so break that down. What does that command actually kick off?
All right, so it tells the Cisco device, hey, go get a file from a TFTP server.
TFTP, Trivial File Transfer Protocol.
Exactly. And copy that file, which is the new iOS image, into my flash memory. Flash memory is where the device stores its operating system persistently.
So it's like downloading a system update.
Pretty much.
Well,
TFTP says where the file is coming from. Flash says where it's going on the device itself. Keeping that iOS updated is, super important for security patches, new features, stability.
Makes sense.
And a pro tip, after you copy it, always verify the checksum like an MD5 hash to make sure the file wasn't corrupted during the transfer, like a little digital fingerprint check.
Ah, good practice. Gotta make sure the update file itself is okay. All right, switching gears to collaboration, voice and video calls. In Cisco collaboration architecture, which bit handles the actual call control and signaling? Options: Cisco Expressway, Cisco Unified Communications Manager, WebEx Edge, Cisco Jabber.
The main component for that is Cisco Unified Communications Manager, usually called CUCM.
CUCM.
Right.
Sounds important. Is it like the brain of the operation for calls?
That's a really good way to put it.
Yeah.
CUCM is the central platform, the nerve center, for managing voice and video calls in the Cisco setup.
Okay.
It handles all the critical signaling, making phones ring, routing calls, managing features like voicemail, conferencing, all that stuff.
It's doing a lot.
It really is. And, because it's so central, understanding its role also highlights why things like redundancy are so critical. If CUCM goes down, well, your phones might stop working.
Oof. Yeah, definitely want redundancy there. Okay, let's swing back to hardware. physical stuff. What should you do before replacing a faulty line card in a Cisco switch? Choices. Reset the switch, disconnect power, save running config, check part number for compatibility.
The absolute #1 thing you must do before touching anything is check the part number for compatibility.
Just check the part number. Why is that the most critical first step? Seems simple.
It seems simple, but think about it. You're swapping out a core component. If you put in the wrong line card, best case, it just won't work. The switch won't recognize it.
Okay, annoying, but not catastrophic.
Worst case, it could cause instability across the whole switch, maybe even physical damage to the backplane. You have to make sure the replacement part number matches the old one, or is a specifically approved compatible substitute for that switch model.
Ah, okay.
It's fundamental hardware maintenance.
Yeah.
Check twice, install once. I've actually heard stories where skipping this caused major outages.
Wow. Okay. Lesson learned. Don't just grab any card that looks similar. Check the number. All right. Now let's talk about managing servers, specifically Cisco UCS. Which component manages server policies and pools? Options: KVM console, Cisco DNA Center, Cisco UCS Manager, Fabric Extender.
In the Cisco UCS world, that central management piece is Cisco UCS Manager.
UCS Manager. So how does it help, wrangle all those servers?
It gives you a single place, a single interface to manage all the hardware in a UCS system.
Yeah.
The blades, the chassis, the interconnects.
Centralized control.
Exactly. You use it to define policies for how servers are configured, BIOS settings, boot order, network identity, stuff like that. And you can create pools of resources like MAN addresses or WWN addresses that get assigned automatically.
So it makes managing lots of servers easier.
Drastically easier.
Yeah.
Much more consistent and efficient than configuring each server individually.
Sounds like a lifesaver in a big data center. Okay, quick one. Those status lights on the front of gear. What color LED usually indicates a hardware failure on Cisco devices? Green, amber, blue, or white?
If you see an amber light, that's generally your indicator for a hardware problem or a serious warning.
Amber. Okay, so amber means trouble.
Pretty much. Green is usually good, normal operation. Blue or white might mean other things. But amber, sometimes it looks more orange. That's the universal, hey, something's wrong here, signal.
Right.
Could be a fan, a power supply, a module issue.
Right.
It tells you to investigate further. It's like the check engine light for your network gear.
Good analogy. Amber equals check engine. Now, how about getting direct access for configuration, especially initial setup? Which connector type is common for console access to Cisco routers? RJ45 to RJ11, USB to VGA, USB to serial, or LC to ST?
Typically, you'll be using a USB to serial connection nowadays.
USB to serial, huh? Serial ports feel a bit retro, don't they? Why stick with serial for console access?
Yeah, you're right. Most laptops don't have serial ports anymore. But the console port on the router, which often looks like an RJ45 jack, provides this really low-level, direct way to talk to the device's command line.
Ah, okay. Direct access.
It's crucial when you first set it up, before it even has an IP address, or if the network is down and you can't reach it remotely, or for password recovery. So the USB to serial adapter just bridges the gap between your modern laptop's USB port and the router's reliable old serial console port.
So it's the fallback, the out-of-band access.
Exactly. Still incredibly valuable.
Makes sense. Okay, nearly there. We need to check interface status and IP addresses on a switch. Which command gives you that? Show interface status, show interface brief, show MAC address table, or show VLAN.
The command you want for a quick summary is show AWIP interface brief.
Show up interface brief. What kind of snapshot does that command give you?
It gives you a really concise table view of all the interfaces that have IP addresses.
Okay.
For each one, it'll show the IP address, the subnet mask, whether the interface is administratively up or down, like if you've enabled it, and the protocol status, meaning if layer 1 and layer 2 are actually working.
So it's a quick health check for IPs and if the interface is actually operational.
Exactly. Super useful for troubleshooting. You can immediately see if an interface is down when it shouldn't be.
Handy. All right, last question from our set. What's the purpose of having a backup configuration file stored in NVRAM? Options: holds running config, stores iOS license keys, allows rollback after reload, contains ARP table entries.
The main purpose of that config in NVRAM is that it allows for a rollback after a reload.
A rollback. So it's like your safety net, your undo button if something goes wrong after a reboot.
Precisely, yeah. The configuration the device is currently using is the running config, and that's in RAM, which is volatile and disappears if you reboot.
Right.
To make settings stick, you save the running config to NVRAM, non-volatile RAM. That saved version is called the startup config.
Okay, startup config in NVRAM.
And that's the config the device loads when it boots up. So if you make changes to the running config, maybe mess something up, and then reboot.
Mm-hmm.
It loads the last saved good config from NVRAM. It lets you get back to a known working state. It's a critical safety feature.
So thinking about all this for you, our listener, considering all these different pieces, what single area strikes you as the most critical for keeping a network infrastructure robust and efficient?
And maybe think about it this way, too. Since everything is so connected, if you had to pick one area to really focus your learning on, to get the biggest bang for your buck in improving network health, which area would that be? And importantly, why? Something to mull over.